Thank you. Sorry.
All right, so we are chatting about the configure stage and all of the categories and features that we work on. Well, not all of them. We're going to try to cover them at a high level. So we are in the categories page here. And as I was saying, the ops section, which we see here, covers everything that has to do with kind of operator support and infrastructure. So things like monitoring, things like infrastructure setup, like setting up a Kubernetes cluster, serverless, which is also a type of infrastructure. It's all the things that we cover in the ops section. So in configure specifically, as you know, we have two groups. So I'll start with the first one, and I'll talk about the features there. So the first one is Auto DevOps and Kubernetes. Well, so I'll stay on the same page. So really, this group name is temporary. I think it's not very good because it's only talking about two of the categories that we cover. It's just that we haven't been able to come up with a better name. I think that in the interest of like having something shorthand, we'll probably call it the Kubernetes group. And the reason is that the Auto DevOps features that we work in are like tightly embedded with Kubernetes. So Auto DevOps have some security components to it. And then it has some operational components to it. And those are the ones that we kind of focus on the most. And I don't know how you think about Auto DevOps, but Auto DevOps, all it is, it's basically it's a CI template, right? And I'm going to show you the template. So hopefully that will click. So this is Auto DevOps. It's basically a template that we provide out of the box if the user doesn't have a CI file. So as you know, when you want to use GitLab CI, you have to put a file on your repo called gitlabci.yaml. So when you don't have that, we will by default use Auto DevOps on your repo. And I think that the main purposes of Auto DevOps are twofold. First is kind of provide modern CI workflows out of the box. So one goal there is that everyone wants to take advantage of modern DevOps practices, but getting started is hard, right? Because getting started has to do with either the system that you're using or the external components that you're using for security and things like that. So we aim to provide the most common workflows that you would use in DevOps. So starting with build, the way we do a build is that you either provide us with a Dockerfile, which is basically a definition of a container image and basically dependencies that you may have with that container. And if you have that, we'll use that to build your project. If you don't have that, we'll use this thing called Heroku Buildpacks. And you can think about Heroku Buildpacks. It's kind of a Dockerfile that covers more ground.
Right. So build is building the code, right?
Build is building the code you have in your repo. That's right. So when you have some code, in order for that code to like be up and running, it needs to be, basically built.
With the dependencies and the libraries.
All of the components that it's using. That's right.
So the users who use Docker build their Docker image on their own and then import it in GitLab, or is it?
Yes. So generally, users will have, let me see what this looks like. When they have a project, like this minimal Ruby app, they will have a file called a Dockerfile. And this Dockerfile basically specifies an image and some configuration settings, like what port to expose, what dependencies you need to use and things like that. And this image, like Ruby Alpine, it's basically the Linux operating system with some dependencies on top. So like the Ruby one will have Ruby specific dependencies, and then you have other images that will have other dependencies. But that's all it is. It's an image of a container, and it's basically an operating system with some other stuff and some configuration. So for example, This one specifically is using port 5000, so that's the port that it will expose to external traffic and so on and so forth.
Right. But the app is also included, the code of the app is also included in the image, or not?
No, it's not. So basically on the page we were just seeing, on this page, all the other stuff is the code for the app. So all of these files and this folder.
Right.
The Dockerfile is just the image of the container. That's all it is.
Okay, so it specifies what CPU or what requirements it has for the system to run on.
Yes, so not only that, but the image that it will use. So as I said, the image is based on a certain flavor of Linux. So it will be an operating system. And it will be an operating system in some cases with some dependencies on it. So like the Ruby one will have some Ruby components installed on top of the operating system.
Okay.
Yeah, and but yeah, so the Dockerfile is separate from the application code. So the application code, for example, is here, and that is like code specific to my app.
Okay.
So as I was saying, if you have that Dockerfile, we'll use that, and that's going to be kind of the fastest way to build your app. And if not, we'll use this Heroku Buildpack. And you know, basically, as I was saying, Buildpacks are, you can think about them as a common way to build applications of a certain language. So if you see, we have Buildpacks for different language. Well, not we, but Heroku maintains all of these Buildpacks that support a number of languages. So we'll use these out of the box. And if you're a user who wants to use a Buildpack that is not on this list, you can specify your own Buildpack. So, you know, the community has built a number of Buildpacks, and basically you can specify a custom Buildpack if you want to build an app that's outside of this list, or for a language that is outside of this list.
Yeah. Okay, so these packs specify how the code is built to run on a container.
That's correct. That's exactly right.
Okay.
So that is kind of part of the build process. And Auto DevOps has also other components like building. I think is kind of the crucial one where we start. If we know how to build it, we'll move on. If we don't know how to build it currently, it will fail. However, we're working on a way to make it smarter where it won't fail, but it would simply it won't run, or it will run, but it won't result in a failure. So it kind of doesn't provide a bad user experience because Auto DevOps is enabled by default. And currently, when you enable it by default and you see a failure, it's kind of confusing. You don't know, what's failing. Haven't done anything. Why is GitLab showing me a failure? And the reason it fails is because we didn't know how to build your project most of the time, or you didn't have CI configuration in place, like a runner or things like that. And that's confusing. So we want to make that smarter, and we want to make that kind of a better experience. But yeah, so then we move on to like auto testing. We do code quality. If you're on a higher tier plan, we do all the security features like SAST, which stands for Static Application Security Testing. And then we do things like license management, container scanning, review apps, all of those things. So all of that happens automatically after we build. And then if you have a Kubernetes cluster configured on your project, then we will deploy it automatically in that cluster. And we provide the ability to monitor what's going on in your cluster with Prometheus, which is an open source monitoring system. And it is cloud native. So it's basically, it's designed kind of to run with containerized workflows, and it works very well with Kubernetes. It has a very robust Helm chart that you can use, and that's what we use to deploy it into your cluster. And then you will see like all of the stats from your cluster, like CPU, memory, things like that.
Right.
That's what we call auto monitoring. And that's basically it. That's Auto DevOps at a very high level. Of course, there's a lot of nuance and detail in how to make it work in different scenarios. So for example, when you need to initialize or migrate a database, you need to do different configuration. If you have like custom elements that you want to use and you don't want to use them out of the box, there's custom configuration for that as well. And most of the configuration for auto DevOps, it's done through environment variables. So in the auto DevOps docs, you'll see that we have a whole section that talks about the variables. And you use different variables for different things.
These are the minus something you put after the command in the terminal, or
no. So this would be. Let me show you where you configure auto DevOps. So here, this is a project that I have with auto DevOps. So if I go into the settings and CI/CD, here I will see environment variables. So variables, and here is where I use each one of those variables for some purpose. So let's go just over a couple. So auto DevOps uses a domain nomenclature that can be quite complex. So you have a base domain, and based on that base domain, we will auto-populate a domain for your app based on your project ID and a number of things. But if you're running a production app, you may want to use like a custom host name like example.com. So the way to configure that is through an environment variable. And just like that, we have, that's one configuration point. Just like that one, we have others. Like if you want to use a custom chart, you would use this one. If you want to use a custom Buildpack, you would use this one. And that's basically the gist of it. So that's for configuration, for database, for security, and for job management. So if you want to disable some jobs, you can also do it through the use of environment variables.
Right. I get the general idea.
Okay. Yeah, let me know if at any point something does make sense or you want to ask me something, please feel free to interrupt me. But that's the gist of auto DevOps. And I think the vision we have for auto DevOps is that, there's kind of an explosion of projects right now. So everything used to be kind of a monolith, a single project. And now everything is moving to be a service, right? So let's say if you had a single app, you may be breaking it in small services that each serve its own purpose, and then you interconnect them all through APIs. So getting started with DevOps, as I said, all of these modern practices, it's hard, it takes time, it takes knowledge. So if you have a CI expert on every team, maybe that's not a problem, but the reality is that people want to get up and running and they're not necessarily an expert. So auto DevOps is the purpose is to democratize access to modern DevOps practices and workflows.
To remove all these constraints that you have. That's right. Don't have a specialist in your team.
That's exactly right. So that's part of it. And actually here in the vision, we have like good snippets that talk about the increase in the number of software projects and the need to provide some sort of workflow and how much time it takes and investment. So it's trying to reduce that and kind of take the friction out and give you modern workflows out of the box.
So what's the most challenging thing about services that you would need a specialist? So let's say before you had services, you produced your code, you tested it with QA engineers, I guess, and you delivered the whole kind of feature. I imagine that was the previous workflow.
Yeah, testing had some level of automation. It has had for a while, and there's different types of testing. But yes, so that the gist of it is you're building this gigantic thing. There's a lot of changes coming in. You need to coordinate changes across groups, making sure that one doesn't break another. And it was very convoluted and heavy, and it didn't allow companies to move fast. So that's why you kind of separate all of those things and ship them individually so you can deliver them continuously.
Right. And what's the biggest challenge that then Auto DevOps solves for in this new world? Is it again the communication between services, or is it?
No. So it doesn't solve that. That is solved by the people that are designing their own apps and how the services intercommunicate with one another. That's solved by them, by how those services are designed. I would say that the biggest thing that Auto DevOps solves is the high barrier of entry that people have to implement modern CI workflows.
So it automates things that people wouldn't usually know how to do manually?
Well, so they put, some of them do know, a lot of them don't know, or if they do know, they may not know what's the best practice.
Right.
Yes, to write out your CI file manually. So basically when you're creating a CI job in GitLab, you have to write the YAML by hand, and you have to write all the stages, and you have to write basically what you want to happen on each stage, dependencies that you may have across stages, and things like that. So there are a couple of things that I think we are very advanced at GitLab, and one of those is best practices. Because not only we see what's going on with users, but we see what's going on internally, and we kind of connect all of those dots. And also expertise with containerized workflows. So, you may see that everybody wants to work with containers, and, it's a very modern way to make sure that your environments are homogeneous and they run anywhere. So with that, and frameworks like Kubernetes, which is a project that allows you to orchestrate all of your containers. There's definitely a ramping up period where people are not experts in neither containers nor Kubernetes. And Auto DevOps gives you very good practices to get started with both.
Right.
So it's solving that problem too, that everybody wants to kind of take part in the container revolution, but they don't know where to start. So that's a big problem that we're solving.
Right. Okay.
Okay. So yeah, it's a very broad topic, and I feel that we could probably just talk about Auto DevOps for a couple of hours. But at a high level, that's what it does, and that's what it aims. That's where its goals are.
Okay, I'll do more reading, I think, before I come back with more questions.
Okay. So before we move on to the next topic, do you have any questions on that?
No, I get the big picture. So
okay.
Yeah, I just need to maybe read the specifics.
Okay.
Thank you, though.
Okay. So let's move on to the next one. Then the next one is what we call Kubernetes configuration. Everybody, both internally and externally, refers to this as the Kubernetes integration. And it's really less of an integration with Kubernetes and more of a way to manage Kubernetes. So it should be, I'll update it to be called Kubernetes management. So it's a way that you can manage and interact with your clusters, starting with, as you might have seen, adding a cluster, which you can do either manually by entering the cluster details, or you can do by adding it from GKE, which is GKE is the Google Kubernetes engine, and is part of the Google Cloud, which is one of the hyper clouds. So the three big ones are AWS, Google, and Azure. And our goal is that you're going to be able to easily add a Kubernetes cluster to any of those top three, at least. And there are others on the list, like DigitalOcean, and some others that may not be as big, but we've also had some appetite for it.
Right.
Number one would be starting from adding your cluster. And then when you add your cluster, you're giving GitLab kind of access to what we call a cluster admin account. And what that allows us to do, yes, go ahead.
You already have an account in Amazon or Google or Microsoft, and then you have a cluster there, and then you add it to GitLab, or can you get a cluster via GitLab?
Yeah, so there are two different workflows that we have right now. So when you go to add a cluster, you can add it right on GKE. So here we said add your cluster on GK, and all you have to do is click here to sign in with Google, and you select the account you want to use, and that's it. You can just give your cluster name, and then you select which project in Google you want to create it in, what zone, how many nodes, and things like that. And just with a single click, it will create it for you. So this is great because if you were to do it manually, it's kind of more clicks. You have to go outside of GitLab and change contacts and things like that. So it's a great experience, but we only provide it for one cloud right now. So we want to make sure that we provide it for other clouds as well that are very.
Okay, so you don't have to go to Google. Okay, that answers my question. If you had an Amazon cloud, then you would need to go to Amazon, create it, and add an existing cluster.
And then add the existing cluster. And that's kind of a more convoluted process because when you create it by default, you may not have the account you need, and you have to do a certain number of steps in your cluster. So
right.
Yeah, it's not as easy. So we want to make sure that it's easy or as easy as possible on each one of those clouds.
Gotcha.
So when I add a Kubernetes cluster, I am giving basically a couple of details. I'm giving GitLab kind of details on the API URL. So it's basically the URL for that cluster, the credentials that you need to log into that cluster, so on and so forth. So GitLab has access to some variables that are coming from that cluster, and GitLab can use those variables on its CI jobs. So even outside of auto DevOps, I can tell GitLab, like I could write a CI job using the variables coming from my cluster without having to specify them manually. So that's a kind of a great feature of our Kubernetes integration. And that in itself is valuable. But then we have kind of other integration points with Kubernetes that make GitLab very easy to use with your Kubernetes clusters. So one of them is deploy boards. And I'm sorry that we don't have an image here. Let me see if I have one up and running on mine. So basically, when you deploy anything to Kubernetes, you're making use of what we call pods. And pods are kind of logical units where that have containers running inside of them. And those containers may share some common components. And then when you make a deployment, you will see those things running here in GitLab. So here, this is what we call a deploy board. So for this particular deployment, I see that I have 20 pods running. And so it's great that you can see the status of those pods right here. Like if my rollout was not complete, I could see how many pods are in process. And while that deployment is happening, you can see this thing being completed until the specified number of pods is deployed. So that's great. Another very nifty feature of the Kubernetes integration is that when you hover on each one of those pods, so it tells you kind of what the pod name is, the status, you can click on that pod and you can see the logs. So basically in real time, what's going on inside that pod. So that's really great because otherwise you have to go to Google or to whichever provider you're using and then locate the pod and then drill down and locate the logs that are relevant. So we're adding a lot of value by doing things like that. So that's one. Another one is that, so here you see a bunch of links on the upper right-hand side of each environment. So one is that you can open the live environment, so you don't have to locate like the URL, try to remember what the URL is, and blah, blah, blah. So here, when I click on it, it's just going to take me to that live environment. And here you see kind of what the URL is, and it's doing all of that automatically for me. So that's one. Another one is the monitoring that I was mentioning. So here, if you use Prometheus, you can see the performance data for your cluster. So here I'm seeing like error rate and latency and throughput and things like that. So there's a lot of good monitoring data that we're providing with the Kubernetes integration. Otherwise, you would have to either go directly to Prometheus or use a dashboarding tool like Grafana to basically see all of this stuff. So the fact that you can see it right within GitLab is also very, very valuable. And then you can customize it to see whatever metrics are meaningful to you.
Right.
So that's very cool.
So these metrics are not available in the Kubernetes dashboard in Google.
Well, so the Kubernetes dashboard is not installed on your cluster by default.
Oh.
So you can choose to install your Kubernetes dashboard, but then customizing it is not as easy as you can in Prometheus. So yeah, maybe we don't have to go through the whole thing because it's going to take us some time. But yes, that's the gist of it, is that it's a lot easier to customize it in tools like Prometheus, because the Kubernetes dashboard has like a set of metrics, and that's it.
And that's it, right?
Yeah.
You need to put Prometheus on top and then either Grafana or something else to visualize.
Well, so you could query, I think that Prometheus has some dashboarding stuff built in, but yes, most people like to use Grafana to see all the metrics that are coming there. So now we also have, as part of this integration, the web terminals. So when you click on web terminal, what this is doing is that it's giving you access to a container that's running inside one of your pods. So this is for the production environment. Here, for example, if you're troubleshooting a problem in production, you don't have to like locate the VM where that container is running and things like that, which it takes time and it can be very cumbersome. You can issue commands right here from this dashboard. So, you know, that's very helpful and it saves you time.
Can you see any of the pods? Do you know in which of the pods you would have problem? So that.
Yes, so if the pod is not running, the pod will change color here.
Right.
Yeah.
So then you would open the terminal to troubleshoot and see what's going on.
That's right, yes.
That's the main thing.
Okay, here it worked. So here, you're inside of the container, so you can, like if you wanted to see what's going on in your Dockerfile, so maybe somebody changed it and they didn't do it right, or they didn't do it to the specification, so you could do it right here. Hold on, let's see, I would say a Dockerfile, and then you can see the contents, and you say, oh, maybe there's not the right port, or whatever, and you can fix it all right here instead of like locating the VM and going to the command line and stuff like that. So that's very useful.
Cool.
So those are, I think, at a high level, the main things about our Kubernetes integration. We have more like technical, detailed things like the ability to do canary deployments. So you can do that basically through configuring more environment variables. But I think that this is kind of the, and well, so another very useful thing is that when you integrate with a Kubernetes cluster, you can configure your CI file to deploy review apps in your branches. So I don't know if you had a chance to interact with review apps, but review apps give you a full running environment of your app that you can test with. And that's a really great feature. Like if you visit any MR today, it'll have like, let me show you this. I think it's going to be easier if I show it. So for example, let's know of a project that I know for sure has review apps going. So this is gitlab.com, and we go to merge requests. And well, all of these are building. This is built. So here, this person updated team.yaml, and you see here this button that says view app.
Mm-hmm.
So when you click on it, you'll notice that the URL is specific to this app, and it has kind of the branch name, and then about.gitlab review app and then company team. So this is a full running GitLab website that is not production, right? It was spinned up only for that branch. And it's great because you can test and you can see how things are looking and feeling in production, or how they will look and feel in production after you deploy this branch. So, you know, using review apps in your CI workflow is one of the things that you get with auto DevOps out of the box, that I think it's a very useful thing.
Nice. And that happens before merge or even after you, but probably before merge.
Before merge. So yeah, so this MR, for example, is open and it hasn't been merged. Once it's merged, the review app will be destroyed, because there's no sense in having it up since that branch has been merged.
Right.
So yeah, that's another thing that is very useful that's enabled by the Kubernetes integration. You can really have review apps in any environment. It doesn't have to be Kubernetes, but using it Kubernetes, it makes it possible for us to provide that automatically with Auto DevOps.
Could you, maybe it's a bit forward, could you track the cost of your application through a review app?
You cannot. No, that would be very cool. I think that when we talk about cost, things are so specific to the provider that you're using to run your compute on. So the cost of 1 hour of VM time, like let's say for a certain size of VM, is going to be different between each one of the clouds. So we should talk and we should think, in my opinion, of course, this is something that we have to discuss. We have to talk about costs in terms of resources. So instead of talking dollars and cents, which, by the way, would be a phenomenal feature, and people would absolutely love it because they immediately identify with money.
Exactly.
But we have to talk about resources in terms of capacity. Like, hey, we see that you're underusing your cluster. You can save 50% if we kill 3 nodes out of the 6 that you have. Do you want to do that? Yes or no? And then doing things like that. So we have to talk about percentages, about resources like VMs, cluster, pods, things like that. And then if I tell you that you can cut it in 50%, it probably means that it's going to be like 50% less cost. I mean, it may not if you're paying more for your Kubernetes masters. But for example, in the case of GCP, you pay per cluster per node. So if you cut half the nodes, you're probably going to save half the money.
Yeah.
But that's how we have to think about cost. That's actually a good segue here. We have one category that is planned, so we haven't done anything in that category yet. And this is something that we have been discussing with the monitoring group about cluster cost optimization. And this is, you could imagine that in my Kubernetes page, I have clusters here. So here, when I click inside this cluster, I could have a tab that says something like cost. And it could tell me, hey, you've been underutilizing your resources by 50%. So if you run this cluster at 80% capacity, you're going to save 50% on resources. Would you like to do that? And then you click yes. And then GitLab goes out to the cloud that you have this running on. And I don't know, this may or may not be doable with only the credentials that we have, but it would be great that we tell you, hey, you could save 50%, and with a single click, we're going to go out to the cloud of your choice. We're going to cut down your cluster by 3 nodes, and then you're in 1 month. We'll come back and say, hey, by doing this, you saved this over months, and well, not in terms of money, but in terms of resources. So that's kind of the pipe dream that we have with that category of cluster cost optimization.
Nice. At the moment, is there any way besides Grafana to see what percentage of your clusters you're using?
Well, so it depends. If you, not within GitLab. So within GitLab, we can talk monitoring in terms of like memory and processor use, right? So here we see that the CPU and the memory use, but that's about it. So we see that the average request is 1.16 and the capacity is 7.3.
So you're waiting.
On this cluster, it's way over provisioned, and I'm probably paying more than I should be paying. So if GitLab knows that, it should tell me, and it should, with a single click, say click here, and let's cut this down by, 70%.
So would that be us or the monitoring team?
So right now, the cluster cost optimization and anything that has to do with Kubernetes management falls under configure. However, this particular category we talked about with the monitoring health PM, and they were open to doing it. Then for a certain set of circumstances, they had to push it back. But I think that whoever gets to it first is gonna do it. I feel that we should do it at least in a very minimal stage before the year is out. That doesn't give us a lot of time, but at least an MVC, so we can, take that category.
Yeah, get requirements.
Yeah.
Yeah.
So that's in a gist what the Kubernetes management category is. Do you have any questions about that?
No.
Well, so one thing that I felt to mention actually was the application management. So I think that you've already experienced this, but installing a Helm chart on your cluster, it's kind of a process that you have to go to the command line. You have to have a YAML file for that particular Helm chart. You have to apply it to your cluster. You may have to create a service role. You have to create role binding. So it's a complicated process. So if you're new to Kubernetes, this may be kind of a high barrier for entry.
What is a Helm chart?
So you can think about the Helm chart as a package.
Okay.
So you know how NPM is a package manager, right?
Now I know.
Well, so yeah, what would be a good term? So let's think about the App Store. So let's do an analogy with the App Store. So the App Store gives you an easy way to install applications on your phone. So you can think about the App Store is kind of the layer that's managing all the packages. Let's say each package is an app. So Helm is the same thing. So Helm, you would say, is the App Store. So Helm is the App Store, and a Helm chart is an app. So a Helm chart, yeah, these terms are basically all new with Kubernetes, and it may not make sense to a lot of people that are just thinking things in different terms and different ways.
Yeah, because now I'm thinking, sorry, but what's the difference between Helm and a Docker, not a Dockerfile, but an image that contains your application?
So Helm is a package manager. Helm is an application. Helm is a program. Helm is a program whose job it is to manage all of these applications that you're installing in your Kubernetes cluster.
So how are they going to run? Which one is going to run first, etc.?
Well, no. So Helm doesn't determine which apps run. Like the user determines which apps run. But Helm is basically, you can think about it like the App Store. So when we go to charts here. So Helm is the application that manages all of the charts. And you could think about each chart as an application. So you can think about Helm as the App Store. So Helm is a program that allows users to install apps on their cluster. Those apps are called Helm charts. For example, if I was to search, for GitLab, let's say. So GitLab has a Helm chart. So you can deploy GitLab onto a Kubernetes cluster using Helm. And right. That would be the equivalent of seeing GitLab on the App Store. And instead of saying the GitLab app, it's just called the GitLab Helm chart.
Right, okay.
So a great point about our Kubernetes integration is that it allows you to install Helm first. And Helm is the package manager, or basically what manages all of the installation of these apps. And with a single click, you can install apps onto your cluster. So for example, if I was to go to the GitLab chart and say, how do I install, and let's not say GitLab because GitLab is kind of it's a complex chart. So let's say something smaller that was designed for Kubernetes. Where's Prometheus? Oh, here, stable. So here, this is the Prometheus Helm chart. So you have installation instructions here on the right. So let's say introduction, prerequisites, installing the chart. So it says to install the chart with the release name, my release here, you have to issue this command, helm install -- name my release. And then the command deploys Prometheus on the Kubernetes cluster in the default configuration. The configuration section lists the parameters that can be configured. So if I go here, I can see like what kind of values I have to give, and that link is not working, obviously. Let's go to the Prometheus repo. I think that's it's going to be easier for me to explain kind of the complexity that we're solving. So Prometheus. So install. So here we say there are various ways of installing Prometheus. Building from source, precompiled binaries, Docker images. I don't know that they're talking about the chart here. No, they are not. Here. So installing the chart. Here we say to install the chart with the release name. And then here is the configuration section. So here are all of the configuration values that you can pass to the configuration section. So as you can see, it's a lot, and it can get quite complex. So as I was saying, with GitLab, you can do this with a single click. So here with Prometheus, you just click install, and that will deploy Prometheus onto your cluster. And then not only that, but once you've installed a certain Helm chart, a certain application, you can uninstall it with a single click. So if you were to uninstall Prometheus from your cluster, not only do you have to get rid of Prometheus, but any of the resources that it created. So if you created a role to run as, or a role binding, you have to get rid of all those things too. So doing that with a single click is a huge advantage. And you see kind of this, this pattern is very popular with people that want to be a Kubernetes manager. So other companies that do this, like Rancher, they aim to do it with a single click. So it's very valuable. And that was the last thing that I wanted to point out about the Kubernetes management category.
I have a question. It's user specific, but just to get an idea of our users. I know most developers don't really give up the terminal. So now we're talking about a single click for installing and uninstalling. Do you think they are shifting towards the UI if it has become less troublesome, or do they stick to the command line?
Yeah, I think that's a good question. I think that it depends on the use case. There may be some companies in which the main persona that is managing the Kubernetes applications is an operator. Like a developer may be doing it if they are developing an application and need a particular Helm chart installed on their cluster. I would say that developers may be using this if they're using like the default configuration for each Helm chart. So one of the things that we have planned that basically we could use as an internal customer, so like the GitLab infrastructure team could use, is the ability to customize the Helm chart before you install it. So when you customize it, you can pass it, let's say, a configuration file with certain configuration values, and then you install the Helm chart. So a lot of operators with more advanced production use cases will need to do that. A lot of developers that are developing and just need, let's say, an instance of Prometheus to test against, they will most likely run it locally. They probably won't stand up a cluster on GitLab. Like people that are doing this, I'd say, are people that are like experimenting with their apps or like testing it prior to deploying into production. So if you're a developer that is deploying their app, yeah, you could probably use this. And if you're using the default configuration, no problem. Now, with that being said, if you're developing for it, if you're developing for Kubernetes, you're probably doing it through the command line. You're probably doing it through the command line, and you're probably doing it locally. However, overall, outside of Kubernetes, I would say that no, developers are not moving towards the GUI. Developers are staying in the command line for sure.
Yeah. Okay.
All right, so that's the Kubernetes management. And then we have a couple of more that are minimal that I want to touch on. So the first one is Chatups. And here, you can think about Chatups about like the ability to execute actions on your infrastructure via chat. So for example, let's say that you wanted to turn a feature flag on or off. You could do that via Chatups. And really all that is that it boils down that it's running a CI job. So the current scope of our Chatups offering is that you can run a command in Slack, and if you have configured your CI job properly, it will go into GitLab, it will run a CI job, and it will spit back the results in your chat client. It will say either I have successfully done this or I have not successfully done this. And the way that you specify a chat job, let's say if you only want to run it through chat, is that you add this line in your CI job called only chat. And that will basically scope that job to only run when it's executed through a chat client, like specifically Slack.
Is that was that a finding from research?
What's that?
That people would only want to execute commands via chat and not go in their terminal, etc.
Well, so it's quite, that's actually a quite common, how do we call this? It's a quite common pattern in software development that you are, let's say, an operations person, and you have a runbook which states that you should do this, 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 and this. As an operator, I may want to give you access to run a job, but not access to the project or the job itself, where everything is defined. But yeah, running it via chat is actually quite common in the software development world. And you can see examples of this today. Like if you go to our production channel, which I'm not a member of any longer, I guess. Let me see. Production. So here there are, let me see. So here, this person ran a Chatups that says feature set routable two-step lookup true. So he's basically setting a flag that was false. He's enabling it by setting it to true. And then the Chatups bot tells you if something was successful or not successful. So yeah, it's great for you, even if it's not an access problem. If you just want to quickly do something in Slack, not having to find a project, a job to run, just doing it with a single command, it's very worthwhile and very valuable.
Yeah, I can understand that. I was just surprised by the only.
Oh yeah. I don't know if that's a common thing for us here at GitLab, but that was done before my time, so I'm sure that it has good
history.
Yeah, good history. So let's say if I wanted to find out Chatups only chat, we probably
should find an issue.
We have an issue about it somewhere, I'm sure. Yeah. I didn't find it on the first page, but yeah, I'm sure it's there somewhere.
Okay.
And that's the gist of Chatups. So the main obstacle that we faced with Chatups is that we would love to provide out-of-the-box Chatups functionality for everyone. But I would say that the main obstacle is that everyone's workflows are different. Everyone's permission model is different. Everyone is concerned about security to a different extent. So doing something that works for everyone is challenging. And that's somewhere where we want to spend more time and gather more use cases and come up with something that's a little bit more robust that works for more people.
That's a general comment. I won't even ask, but after Slack, probably something else will come. Like before Slack, there was another way to communicate. Maybe that's going to be an issue at some point or not. You don't think so?
I think it's an issue already. So it's we already have like Microsoft Teams, which is a huge tool within the Microsoft ecosystem, and a lot of like big enterprise companies have all the Microsoft stack, and they use something like Microsoft Teams. So yeah, it's an issue already today, but there's also Mattermost, which is an open source chat client that ships with GitLab. So we should have like support for that out of the box. So I think that we can only do what's I would say like most requested by users today. Yeah, sure. Like we're doing Kubernetes very heavily today, but tomorrow something else might come. That's not Kubernetes, and Kubernetes will no longer be relevant. But I think that that's one of those things that we have to worry about it when we get there.
Yeah.
And worry about it now. And we have to design and like ship features for the things that we know are widely used today. But yeah, I think that that's a problem across any
industry.
Software development.
Industry, yeah, for sure. It's evolving so much, including languages, etc. That's why probably agnostic, like Kubernetes agnostic technology came, so that you don't have to depend on specific configuration, I guess.
That's right. So that's it for Chatups, and then we have a couple more that I wanted to chat about. I know that we're kind of running out of time, and I want to be respectful of your time. So my next meeting's at 2, so we could go for an additional half hour if you want, or we could table it and continue like later today or tomorrow.
I'd prefer the second option. Maybe it's 6:30, so.
Oh yeah. Sorry, I didn't realize. It's quite light in London. Yeah.
Yes. Once the time changes, then we're gonna go back to normal hours. But yeah, now it gets dark around 8 still.
Okay. So you're moving, right? You're moving soon?
Not yet. No, it will be a year, I think.
Someday.
Yeah, you'll hear me cheering when when I'm going to move. But for now, I'm here.
Okay, cool.
We might need a second session like.
Yeah, we didn't talk about runbooks, chaos engineering, serverless, or infrastructure as code.
So yeah, maybe I'll schedule something, a follow-up.
Yeah, let's do that.
Hopefully, I'm not wasting your time.
Not at all. Not at all. This is, I think this is time very well spent, and I really want you to have as much knowledge as you can because, you know, I have a big responsibility of enabling the workflows and the UX for the stage, which is quite complex. So we need to be on the same page for sure. So it's a great investment of my time. Never feel that when you put time on my calendar, you should never be concerned that it's not a good use of time. It always is.
Okay, thank you. Maybe some things I will understand later, but I think it's useful to just, now I have the recording. When I learn more about DevOps, I'll come back to the recording and see what I didn't understand. Maybe I will be able to. So it's very useful.
Great. If you find it useful, others might as well. So
yeah.
I would say maybe consider uploading it to Unfiltered.
Okay.
Of course, that's your call. If you don't feel comfortable doing it, please, you can ignore that. Yeah.
Unfiltered is a Slack channel?
It's a YouTube channel.
Oh, YouTube channel. Okay. I wasn't aware of it. I'll check it out.
Okay.
Okay,
cool.
I'll schedule a follow-up. I'll check your calendar.
All right, sounds good.
Thank you very much.
Thanks, Maria.
Have a lovely day.
You as well. Bye-bye.
Bye-bye.